All right. So today we are starting the front end module where we're really going to dive into this technology called React.js and learn the modern way of building front ends. A lot of the DOM manipulation that we did in the full stack module, really all of it will get replaced by React.js and we'll learn how to build much more interactive applications. This is sort of opening up a deep well. React is really cool. I think it is way more complex than people give it credit for. And I think JavaScript is also way more complex than people give it credit for. Um, so I think some of this will start to feel familiar, and then we may run into some concepts that feel very different along the way. And that's okay. So today we're just going to get introduced. We're going to start not even with React, but with the Node project manager, which is sort of like pip for Python. That's how we install different packages. Um, and then over the next several days, we're really going to dive deep into working with React, and we'll see how to use some UI libraries that bundle up a lot of CSS. We'll, in fact, see testing in React, and we'll learn how to build what's called a single page app, a pretty rich front end application. Um, Today's lesson and pretty much all the code we'll be writing is here in the curriculum, and I'll be pushing stuff up to demos and notes as well. So today we're going to learn about the Node package manager, excuse me, not project manager, NPM. We're going to learn some basic commands. We're going to learn how to make a project, how to install JavaScript libraries, dive deeper into NPM and see how we keep track of what we've installed, NPM scripts that let us run um, other people's JavaScript libraries from the command line, how importing works in JavaScript. We're going to see some JavaScript .map and .filter functions, which might ring a bell from week one, but which we haven't really seen. Well, maybe you guys have been using them a little bit. Were you guys doing some mapping and filtering in the full stack module or not so much?
Only when we wanted to.
It's a good reason. Um, we are going to be doing a ton of this with React because JavaScript follows what's called a bit more of like a functional programming paradigm. JavaScript has classes, but you don't really use them. You use this sort of superset, sort of super powered version of JavaScript called TypeScript when you want classes and real object-oriented programming. JavaScript has objects, but it's not really object-oriented in the way we think of Python OOP. So as we get into React, we'll see we're doing a whole lot with these functions and higher order functions and stuff. And then instead of fetch, we're going to use a library called Axios to make our HTTP requests. And if we get to it today, we'll see a little bit about testing. This is going to be the first part of our lecture. Once we're kind of warmed up there, we're going to dive into learning. Today's really about how to create a React project and the structure of a React project because it has sort of a set structure. So today is an intro day. Some of this will be familiar, some of it might be pretty new. Just don't hesitate to ask questions and speak up along the way. And do folks have any questions before we dive in? Nick, yes, sir.
Do you want us to attempt to follow along or by programming on the side or just pay attention?
I would recommend paying attention.
Okay.
Yeah, it's ultimately up to you guys, but that's sort of our default recommendation. Um, and I think today's a good attention day. Um, Real quick before we dive in, can I just get a show of hands? Like, how many people have worked with React.js before? I know one or two folks have here. Kevin, um, Jay. Yep, I remember you telling me about that, Jay. Carlos. Cool. So a couple folks. Um, what did you guys think about it? Did you like it? Was it different than other kinds of programming you had done before? Was it similar?
Compared to vanilla JS, it's a lot easier, yes.
Cool. Yeah, I would agree. A lot of the DOM manipulation that has been maybe more manual and persnickety is going to go away. Kevin and Carlos, what did you guys think about React?
As long as you know which Lego pieces to use, it works pretty well. It's just like, I don't know.
Yep,
It's a lot easier than typing everything out.
yep. That's a good way to describe it. And React, as we get into it, I'll talk a little bit more about the history of it. A large amount of my professional software engineering experience was with React. Um, so I have been fully Stockholm syndromed by JavaScript. And part of the challenge and the history to remember here is how all this stuff relates to the browser, right? And if I open up and have you all seen the console before? I'm guessing many yes. Anyone seeing this for the first time? Cool. So as we get into React, the console is going to be like your command center because it's not just the console, it's also the network tab where you can see network requests that happen and requests and responses and what's in a response. And in this case, this is some image asset or something. I, in fact, even have a Chrome extension installed here called React Dev Tools that we're not using right now and we don't have to worry about, and we'll see later. But, JavaScript was originally created to run for the web. So when I run this code, where on my computer is this code getting executed?
The browser?
Yeah, it's getting run in the browser. And over here, when I run this code, where is this code getting executed?
On your system, I guess.
Yeah, on my system, not in the browser, right? Um, it's getting executed, it's getting run from whatever directory this is. It's getting run inside this shell session, which for me is then, inside my operating system. Um, so we have two different environments that we can run JavaScript in. And this is just something that's good to file away. Um, and can anyone tell me, like in a nutshell, what Node.js is?
Node.js is just it's a an interpreter of sorts, right, for JavaScript so that it does not depend on your browser to run it.
Yeah, that's a great description of it. And in fact, once I get my diagrams up here, we can dig into this just a bit more. And this is just, I like to give a little context before we dive in too much to stuff. Um, Inside the browser, there is something called a JavaScript engine, um, or interpreter. And this is what runs and executes JavaScript, like we just saw, or like just now, if I go to view developer JavaScript console, right? And because this is running in the browser, I can interact with the DOM with my JavaScript. Document get element by ID, which we've all seen. I can use the elements inspector. It looks like there's a div here with an ID of root, which we'll actually learn about a bit more. And I can write JavaScript here that does stuff. Um, and when I run this, the JavaScript is running inside this JavaScript engine here. Um, This JavaScript engine has a name. For Chrome, anyone know the name of the Chrome JavaScript engine?
I think it's V8.
V8. Never mind.
Yeah, exactly. Exactly. The Chrome JavaScript engine is V8. Safari, I forget what it's called for Firefox. It might be called SeaMonkey or something crazy like that. If someone can correct me, please do.
Spider
Um,
monkey.
Spider Monkey. There we go. I was in the ballpark. So,
C
Google
also starts
their
with an
own
S.
JavaScript engine. What was that?
I said C also starts with an S. So we're good.
Yes. Yes. And I'm sure there is some sort of code library or project out there named SeaMonkey because it's too good of a name not to take, though I don't know what it is. Um, Google made their own JavaScript engine, Apple made their own, Firefox made their own. Google, being Google and an exceptional software engineering organization, made theirs really, really good and really, really fast. Because the easier it is for people to use the internet, the more ads they see, the more money Google makes, the more they get to hoover up our search data to, train their AIs to take over the world. And that's sort of been, how their business model for ages. But so at some point, someone said, "Hey, V8 is getting pretty fast. JavaScript has some interesting properties as a language. Unlike Python, like certain operations aren't blocking. It's sort of what we call asynchronous. What if I take V8 and wrap some libraries around it so that it can interact with the operating system and stick it on my computer?" And thus Node.js was born. And the idea was sort of for Node to be good for like chat servers and stuff like that to take advantage of the asynchronous nature of JavaScript. So Node.js is actually running V8. Um, and if we do maybe a little Google search here, we might be able to find an image. Let's see here. Yeah, these are all a little more complicated than I want. This one is good. So Node.js takes that V8 engine, which you guys can see over here. It runs our JavaScript code, and they call them bindings, and it interacts, and it's basically a wrapping layer, so it can talk to the operating system. So this is a little in the weeds and a little off topic, but I think it's useful to have some of this context to kind of understand the technologies that we're using. But this takes us back to what we really want to cover today, which is now that we understand a bit more about Node.js, let's see how to use it, right? Um, and let's see how we can use modern tooling around it. Um, I've been talking for a bit now, so I just want to pause and check in and see if folks have any questions. Okay, cool. Let's talk about NPM. So NPM is the node package manager. It's the command line tool we'll use to install all sorts of JavaScript libraries. One we'll be installing in a little bit is called Axios, and it is for making HTTP requests to the browser. You can go to this site, npmjs.org, to search packages. Usually, the most important information is right here on the side. You want to see the weekly downloads. You generally want to use packages that are very popular. It's always nice to check the version. And then I like to pull up the GitHub link when I'm using a new package. And often they have a link to, the documentation. The getting started page is very useful to see. But I like to look at the GitHub a bit as well, and I'll just kind of poke around. So NPM is a package manager for JavaScript, but we also use it to create projects because we have to manage the installation of all these different projects. And way back in InstallFest, we installed Node.js and we also installed NPM. And is my font size okay here for everyone with VS Code? Awesome. And if I type npm space dash v, I'll see what version of npm I have installed. It looks like I have version npm 3. I'm in the directory part 1 of our lecture, so I'm going to type npm init to start a new project. And it gives me a sort of series of prompts. You can actually put pretty much what you want for most of these. This is going to create a file for us. And I can give my project a name. I can give it a version. Um, let's try. Maybe does it want the 3 versions? Yep. I can give it a description. It's going to have an entry point is the program it will run by default. Let's give it an entry point of index.js, which is actually more common. We haven't written any tests. Let's leave that blank. There's no Git repo. We can add some keywords. If I want, I can add the author. I'm not going to worry about licenses. We'll leave the type as common.js for now. And I can just hit enter for yes. And now what's happened is it's created a file named package.json. This other file, tasks.json, I had copied in here before. And this looks like the JSON we know and love, the JavaScript object notation, right? Does this ring a bell where there's a key and a value? And the key always has to be a string. And the value can be a string, it can be an array, it can be a number. And we see these properties here from what I typed. And then there's this really interesting field called scripts, which we'll come back to in a minute, which is in fact a little nested JavaScript object. And we'll see here when we install packages, things get added to package.json. So first, let me just make an index.js file so we have it. Let me in fact just remove hello.js. And now let's use npm to install Axios. And I'm going to give it the save flag so it will not only install Axios, but save it, and we'll see just what that means. So 2 things have happened here. My package.json file has been modified, and there's now this dependencies object. And these are the different libraries that my program depends on. It can't run without it. And we see here Axios version 1.10.0 has been installed. The first number here is what's called the major version. The second number here is what's called the minor version, and this is called a patch version. And the rule is like patch changes should never break anything. Minor changes, I don't think should ever break anything either. But if you're updating from version 1 to version 2 of Axios, you have to check their change log document to see if the way Axios work has changed so dramatically that it could break your code. So that's called semantic versioning, and it's not critical, but it's good to know and something that we can dig into later. And if you look it up, you can see that there's a whole description of this, and it's a pretty standard way of versioning stuff. And then the little caret here has a meaning, but we're not going to worry about that too much right now. So that's one thing that's happened. Another thing that's happened is this directory named node modules has gotten created. And all these other things got installed in here. And here's Axios. And if I look inside the Axios directory, it actually has its own package.json. Axios is also an NPM package. And there's a lot of stuff in here. But if we scroll down, we see development dependencies. And then I thought there would also be, there we go, dependencies. So this npm package depends on some other npm packages to run. And then there's a list of recommended dev dependencies for when doing development work. And in fact, if we look at the names of these npm packages, we can go ahead and we can look them up. And we see it's some sort of replacement for Node's HTTPS that follows redirects automatically. So something to make Axios work better. And if I look here inside this Node modules directory, lo and behold, follow redirects is in here as well. And this is also an npm package that also has a package.json that very well may have its own dependencies. And this one has some dev dependencies. So, this is sort of the curse of npm is installing one library or package installs a whole bunch of others as well. The great part is it lets us leverage software other people have written and build powerful open source software, but it can be a pain in the butt. To help manage this, there's also a file named package lock. Because if we look at package.json, we don't see all the things that Axios depends on, just Axios. But Axios depends on like 50 different things. So what happens if the follow redirects library has a breaking change? Well, then we're in trouble. So package lock JSON was introduced. It didn't exist back in the day, and this has the exact version of every single package and every single package that all the other packages require. So this package.lock.json means I can install the exact version of everything that I want. And in fact, if I delete that node modules directory and I run npm install, npm will look at the package lock JSON and install those exact versions. So node modules, we don't really want to check into version control. I don't want to put that on GitHub. It takes up a lot of space. I want the package lock file. So I'm going to make a .gitignore file. And in there, we're going to tell Git to ignore the node modules directory. And now if I did git status, note that there's nothing in here. Let's just do git add dot. And if I do git status, we see all these new files, but no node modules directory because the git ignore is ignoring it. Along with deleting the node modules directory, I can also safely delete the package.lock JSON. Sometimes you might need to do this if you've gotten into trouble. And then npm will just use the package.json file to install dependencies. And it installed Axios and then built everything else up again. So the moral of the story here is we really care about package.json and package.lock.json. This node modules directory is just generated from that, and we can safely delete it anytime we need to. And we don't want it in version control. And it's where all the actual code for these dependencies live. So this is probably a good pause point. And I just want to check in to see if folks have questions or stuff that you all are curious about. Nick, yes, sir.
So if you were to delete both package-lock and package.json, then you'd be in trouble, right? Because it wouldn't
Exactly.
know. Okay.
Yeah, great question. And in fact, we can do that. Um, so now if I run npm install, it's not happy. And the error right here, it says could not read package.json, no such file or directory. Yeah, great question. Carlos, yes, sir.
So this might not be too important either, but um, so let's say like, could you ever have conflicting like versions of a dependency? So let's say you have Axios and then your second dependency two, whatever it is. Let's say Axios depends on library one, version one, but the second dependency depends on library one, version two. Would there be an issue? Like, does it install both versions of that library or?
You absolutely could have that problem. That is a really good point. It would probably install both versions of the dependency. Um, Dependency management is a bit of a rabbit hole. There's something called peer dependencies that are for handling that sort of situation. In general, NPM has gotten good enough that you won't have to worry about that most of the time. But that is a very good thing to be thinking about.
Thank you.
Yeah, absolutely. Yeah, great question. Great question. I think we actually saw a peer dependency with that this follow redirects library um when we were poking around. And I think in fact if we go to their GitHub and we look at their package.json, let's see, do they have a peer dependency? Yep. I'm honestly not sure what peer dependencies meta does. I would have to look this up. Um, it looks like whatever this debug package is optional. Um, and in fact, let's look up peer dependencies. Um, yeah, I'll be honest, I always have to kind of reread the instructions for these things because they get tricky enough. So I'm not sure I could describe peer dependencies effectively off the top of my head. Um, but I think this is in the ballpark of what you're talking about. Um, yeah. The short version though is like each package can specify its own requirements in the package.json. And then like you were saying, like if two versions of Axios need to be installed, so be it.
Yeah, thank you.
Yeah, great question. I think one other person had a question as well.
I had one, but I figured it out.
Okay, awesome. All right. How are we doing? Because I know I went into a little bit of a rabbit hole there with the node module stuff.
I'm not sure if I was supposed to follow along and install stuff. I tried doing that. Um,
Yeah, I would recommend not coding along today.
okay, perfect.
Yeah. In general, our recommendation is not to code along. If you want to, you can, but it's up to you. And I honestly think it's going to be easier not to. To be honest, maybe especially with React, because we're going to start hitting some very sort of Reacty concepts over the next couple days that are going to be a bit newer. With npm, I need to rebuild my project. If I add -y, it will create some sensible defaults for the package.json, so I don't have to go through that whole manual command line process of specifying each thing. And then let's go ahead and just install Axios again, because we're probably going to use it in a couple minutes. By the way, if I want to uninstall a package, I can use npm uninstall. And note that that gets rid of it from the package.json, and I'm pretty sure it does from the package lock.json as well. And then finally, I can run npm list, and this would list all of my dependencies, the top level dependencies here. So keeping your package.json up to date is really important. You should never modify this package lock JSON file, by the way. If you find the need to modify it, something has almost definitely gone wrong, and you should be talking to an instructor or a TA. Deleting it is okay if you feel like you run into an issue. deleting node modules is always okay. Every now and then something just gets screwed up. Package.json, you can modify manually. I would recommend trying to like avoid modifying the dependencies object here. It's better to do npm install to install the most recent version, or you can specify like a version to install. And then as you saw, there's the uninstall command as well. All right, we've covered a lot of ground here. We've seen what package.json looks like, the different parts of it. We haven't really talked about this main property here. We haven't talked about scripts. We'll come to those in just a minute. I think keywords, author, license are more self-explanatory. Let's see. Why don't we should we take a 5-minute break and then we can pick the ball back up with we'll probably dive into talking a bit about scripts and the main method and stuff like that. Awesome. Let's do it. Thank you, everyone. Get away from the screen, grab some coffee or water, and I will see everyone in 5. All right. So we've talked about npm. We've seen the basic commands for installation and stuff like that. We've made an npm project with npm init. We've installed dependencies. We've learned more than we ever wanted to about package and package lock.json and the node modules directory. Let's talk a little bit about what an npm script is, and we'll talk about importing and modules, and then we'll get to kind of like mapping and filtering and using Axios. So over here in this package.json, there's this very interesting directory named scripts. And if I open up this index.js that I haven't done much with, but let's add a hello world message. Well, I know how to run my program. I can do node index.js. And that works just fine. But once we start seeing how to import other packages into our JavaScript code, npm packages that we've installed, this is not going to work fine. And we actually kind of need to use npm to run our program. And an npm script is just a command that we can run from the command line, but it gets run sort of within the context of the npm program. So npm can sort of feed some information into Node.js. So now that I've created this npm script called start, I can just do npm run start. And we see that sort of prints out a little bit of metadata about the npm project, and then it runs the actual code. I can run npm test, and it prints out this command line message, no test specified. The echo command is a shell command, a command line command. So for instance, this hello script is just going to print hello world. And for like really common npm script names like start and hello, these have become standardized. If I want to, I can omit the run in my command and just say npm start or npm test. If I do npm hello, that is not going to work. Honestly, for simplicity, getting started with scripts, I just recommend just do npm run all the time until you get used to it. So I just want to check in and see if folks have any questions about npm scripts.
So a good way of thinking about this is like npm is a class, and then you're just adding methods into the package.json. So that way you can like run new methods.
Yeah, that is one way to think about it. And you definitely captured the essence of it. I would just avoid I would not use those terms, right? Because it, like with classes, you have inheritance. We don't have anything approaching that. Methods on a class, they same similar goals, completely different. It's like an electric car versus an internal combustion engine, a gas car, right? Like the steering wheel's the same, engine's completely different. Um, I'm not sure if I have a good metaphor, but maybe I think I would recommend start thinking about it in terms of like packages and dependencies and names. And it is similar to class. The concept here is really sort of namespaces. Andy, yes, sir.
I'm not sure if I lost you at some point somewhere when you were talking about NPM, but what is the essence of doing start as opposed to just doing a node and then node one of the JavaScript
Yeah,
file to run it?
absolutely. Um, we haven't really seen importing in a JavaScript file yet, but once we do, as you guys have discovered from importing with Python, like import from the import path starts to matter an awful lot. And NPM lets us control that. And it makes sure that everything kind of works with the same import path. There can also be what's called environment variables that get created that get injected into our code that we need NPM to use. NPM sort of gives an extra layer of context. But to be honest, I feel like I did not answer that question as well as I could have. Do we need to do NPM start instead of just node? Well, consistency is actually a very good point. Consistency starts to matter a whole lot more because it means with any NPM project, I can pick it up and I know that start will run the program. And this, as our projects start to get more complex, which they will really soon, that starts to matter. This portability is actually an excellent point because if I'm a DevOps engineer and I'm writing code to start up a web app on a server, it can be really useful to know I can just run npm start. Um, and then there's, this is sort of the point that I was mentioning about sort of integrating with the npm ecosystem. So actually, I think the AI did a pretty good job of sort of explaining here. Does that help answer your question a bit?
I think I get the gist. So it's like once your project gets larger, you might get lost into like which program to run. Is that what you're trying to say?
Yeah. And also imagine you're pulling down someone else's program, or
Oh,
imagine you're writing code to deploy someone else's program to a web server and automatically start it. If there's like
that
a standardized way to do everything, it makes life a whole lot easier.
that makes more sense. All right.
Yeah, great question. Great question. We'll see this really soon once we get into React because the project is going to get a whole lot bigger. Yeah, great question. All right. Let me actually hop back to our README just to orient myself. There we go. So we've talked about scripts for starting and stopping. And this actually is a really good segue into this next topic of how do I import stuff. And let's just start with this tasks.json file as an example. Um, JavaScript has two ways of importing things. And let's make this there's an old way which uses this what's called a require statement. And let's run this code just to make sure everything is working. And I can see that indeed this JSON file was imported. The value of this JSON file was read and assigned to this variable tasks. And then when I print it out, I see that array of objects. It used to be this was the only way to import stuff from one file to another, and it has some limitations. For one thing, like require will actually execute the whole file. For another, you can't do this in the browser, which is a real pain in the butt if we're writing React code that's not getting run in Node on the computer, but getting run in the browser. Um, Also, the newer way that's called ES6 or ECMAScript 6 modules has some other advantages. And let me just go ahead and type this out. Some of the advantages are going to be greater compatibility. It's now supported in browsers. Um, there's something called like static analysis, which is makes it easier to catch errors. Um, Easier to only import the bits of code you need. Things that are called like tree shaking and are a bit more advanced. It takes a little more work to set up. Because the way I would do it is I would say import tasks from tasks.json, and I can actually add a statement asserting what type of thing this should be, which is really great to help avoid typos and errors in my code. And let's comment this old way out. We're going to run this though, and we're going to run into a problem. And we see an error. And we see the error itself is cannot use import statement outside a module. So Node.js doesn't really think this file index.js is a module. But then this part of the error message gives us a really important hint. To load an ES module, set type module in the package.json, or use a .mjs extension for the file name, which we don't want to do. And pretty soon this will all get automated for us. But to use the modern way of importing stuff and having modules and having namespaces for code, the same way a Python file is a module that we can import from, we need to add this to our package.json. And let's see, duplicate object key. Oh, because the type is already down here and I just didn't see it. And VS Code gives us this really nice hint explaining what's going on. When set to module, the type fields allows a package to specify all the JavaScript files within our ES modules. So now, let's see, what did I do wrong here with this assert? Well, we'll come back to the assert. And it looks like I have another error. Need an attribute import of type JSON. So this is the same error that it's giving me. So I clearly did something silly here. In fact, I'm just going to Google this real quick because I have some sort of typo that my brain is not catching right now.
Is it possible that you replaced the type with the new thing that you were trying to do, the module? Because you
Let's,
didn't add it, you replaced it.
I think the issue may have been I had some quotes in the wrong place. Nope, import tasks from tasks.json, assert type JSON. What were you saying, Andy?
When you were editing the package.json, you were trying to add additional type, but you replaced the module. So originally there was something else already at the type.
Oh, no, that part is okay. It defaulted to CommonJS as the old sort of module way of imports with require. So this is the change we actually want to make. I got a little confused. I forgot this was here and I was adding it up here. But it doesn't matter where in the package.json it is. Let's see if this works. Unidentified. So this is almost definitely something simple that is escaping me. Um, tasks is JSON. This is index.js. Assert type JSON. Um, let's just Google this syntax error. If I can't solve this in the next 30 seconds, we'll just kind of switch gears. So I'm a little out of date. Apparently, the AI answer is a little out of date, and our curriculum is a little out of date too. It looks like in Node version 21, the assert worked just fine. And but with Node version 22, speaking of breaking changes, this is a perfect example of a breaking change with a major version change. We're supposed to use the keyword with instead of assert. This is also the beauty of the internet being created by programmers. If, as you guys have probably discovered by now, if you paste in an error message, 5 gets you 10. The first response here, the Stack Overflow one, was correct. And this also shows some of the limitations of AI. Let's see how we do now. And lo and behold, our program finally runs. We hit a little bump in the road there, but we now have our code running just fine. And if I had another file, let's just say, well, I'll pause before I talk too much about importing and exporting. Let me just see what questions folks have or what people might be curious about. Okay, cool. Let's do a little bit more with importing and exporting. Because I think it's good for us to see, and then we can take another break, and then we'll actually start writing some code using map and filter. So I'm just going to make an example file here. And let's make a function that just says, say goodbye. And let's just have it console log and say goodbye. Now, over here, if I try to do import say goodbye from my module example file, and we can just in fact run it. First of all, the fact I didn't get like auto completion there should be a warning that something is not correct. And we see this error that says the requested module does not provide an export named default. So we can't just create a function and then import it. We have to tell this JavaScript file, now that it's a module, what to export. And a default export means that we'll talk about what a default export is in just a moment. For now, don't worry about the default keyword. And now our code runs just fine. Um, and in fact, if I wanted to, I could do export default function say goodbye like that. And that would work fine too. Now, I might have some other functions in here. Maybe I've got like a default message. And maybe I decide that I want to use it in here. Maybe I decide that for some reason I want to be able to also export this as well. Or maybe I have an arrow function. Um, that's also a goodbye message. Well, how do I export multiple things? The default is only for one thing, as the name default sort of implies. But if I add an export statement in the front of each of these, what I can do over here then is I can have what's called named exports. So this is a default export, and then these are examples of named exports. And if I'd done it like this, I could do export another goodbye. Oh, it actually doesn't like that. I apologize. The syntax can get a little funny. This is usually the easier way to do it. And over here, we can print out our default message and we can run another goodbye. And so now I can have a default export and I can have named exports. And the default export is there because it indicates to other programmers what the main export is. There are some actual differences. For instance, with the default export, I actually get to control the name of it. Because the idea is by default, it exports this thing and then I get to name it whatever I want. And if I need to give an alias, I can use the as keyword. If I have some other variable with the same name in the file that I'm importing stuff into. So this covered a lot of ground here. So I just want to check in and see what questions folks have. On a practical level, we'll very quickly see patterns that we can follow so we don't have to memorize all of this, but I did kind of want to walk through the different ways that stuff gets exported. Keegan, yes, sir.
So if you're exporting by default that function say goodbye,
Mhm.
if you don't export default message, will it still call that variable?
You mean if I don't have,
No.
what's the change?
So don't your constant default message, if you don't export that, will the say goodbye function still console log the default message?
You mean if I get rid of these statements right here?
No, sir.
I might be misunderstanding
Six.
them.
Line 6, if you
Oh,
delete the export,
if I don't export this, will it still work over here?
will it still because you're calling that constant variable in your say goodbye function, right?
I see what you're saying. I see what you're saying. Yeah, great question. I see what you're saying, and thank you for explaining. Right, I I declare a constant right here. Um, right, you're saying if I do this, I declare
Yes.
this constant. I'm using it in here, but then I'm also importing it as a named import. So let's actually run this and see what happens. So we actually run into an error right away here. And the error we see is the requested module does not provide an export named default message. So this is where JavaScript, and I think Python works this way too. Um, Within the namespace of this function, this variable exists. And when we import this say goodbye function, and let me go ahead and get rid of both of these, and we'll just comment that out too. Oh, when I import this default, it's called a closure. JavaScript realizes, oh, I need this variable. So in this little bundle of memory that gets imported here, inside this namespace, I'm going to actually create this variable. So sort of under the hood, JavaScript does const default message equals this is the message. And so that's why, you know, even though the variable is declared here and used here, and we don't export this variable, this say goodbye function works. And let's rename this to be just be say goodbye just fine because this variable is within the namespace, but we still get the import error if we tried to import this other variable because outside of this namespace, this guy is not exported.
Gotcha. Thank you.
Yeah, great question. And we touched on that sort of question of like memory and closures and namespaces like a little bit on week one, but it's definitely something worth digging into because we move through it pretty quickly. Yeah, so awesome question. The real world scenario for this is like writing tests. Sometimes it's useful to like have this stuff for a test or just for flexibility. Um, Most of the time when you have named exports, it's like this, where it's other functions or stuff like that. Yeah, great question. What other questions do folks have? Andy, yes, sir.
Um, is it possible just to import the module example.js and then not have to um, granularly just specify which parts of the document I want to import? Because I imagine this gets really problematic when you're dealing with a larger program.
Well, yes and no. You can do some things. I can, I don't need to use a default export. I can just have named exports. Uh, and let me get rid of the, let's add this back as a named export.
But what I mean is not having to constantly export each thing that we are working on,
Right,
like variable and whatnot, function.
right. Yeah, the short answer is maybe. I don't remember off the top of my head. But you actually don't want to.
Okay.
Um, yeah, like that sort of used to be how it worked, where like what you're actually exporting under the hood is one big JavaScript object. And you kind of get that hint because we see this sort of object destructuring pattern here. And I do wonder if we, import everything from, I don't, I'm not sure if this is gonna work or not. So it works.
Isn't that just pulling the default
Yeah,
function?
yeah, it is just pulling the default. And if we get rid of the default, we may run into an error. Let's see. And we run into an error. Yeah, it with the old way of doing it, the require the common JS, you actually did this sort of module dot export statement, which it doesn't seem to want to let me type. And you made it an object. And then here you like here I would put like default message. I would put another goodbye. And then if I had say goodbye, I would put it here because I don't think default exports existed. Um, but what ends up happening is at first this seems like a lot, but it actually ends up being good because the real problem isn't like typing these import statements because the editor gives us autocomplete and helpers and stuff like that. The real problem is when I have this another goodbye method and it's imported in 50 different files and I don't know where it's used because I need to modify this code, but I don't know if changing it is going to break something else or not. And so having explicit imports like this is actually a huge benefit, right? Because it lets my editor, let's see, go to find all references. It lets me, if I had this in a bunch of different files, I could just do a global search. But find all references is a bit more structured. And and this is a very real problem where I want to change this code, but if I don't know where it's imported and used, there's no safe way to do that.
Okay.
Yeah, great question. I know like this stuff feels like a lot of boilerplate at first. You'll get used to it very quickly, and also once you start debugging your personal projects, which will be much bigger, you will appreciate the value of explicitness. Yeah, great question, man. Um, awesome. We have covered a lot of ground here, and I know I went into depth here a bit. Why don't we take, we've been running on for a bit. Should we take 10? Yeah, let's take a 10-minute break. What we'll do when we come back is we will see map and filter in action a bit. We'll see Axios. I'm going to skip over Jest for today. And then we'll take like a short little break just to let our brains rest, and then we'll dive into React. Sound good? Awesome. Great questions, everyone. I know we're diving deep into this stuff, but we're setting it up so that when we have a React project, it's not a black box and we'll be able to kind of fiddle with the bits we need to. So thank you all. Keep the questions coming, and I'll see you all in 10 minutes. All right. We just did a pretty deep dive of exporting and importing with ES6 modules, and we saw named exports and default exports. And in fact, just to, a really good point was raised. And let's look real quick at module examples. We've got a named export here, a named export here, default export here. You really want to leverage your editor. And it should be. I'm a little surprised I didn't get autocomplete there. But now we're getting autocomplete, right? And so this is why it's in fact not too painful to be explicit in your import statements. And I wonder why that I'm not sure what I got wrong there syntax wise, so I'm not going to worry about it too much right now. Okay, I got a little lost in the sauce there, but let's switch gears. Let's talk about working with these tasks. So let me go ahead and just sort of comment some stuff out. I like leaving that hello world there as a kind of just check that the file's working. And let's talk about .map and .filter. So I've imported these tasks and it's a bunch of JSON. And in fact, let's put the tasks up right here on my split. Now, I want to be able to manipulate and work with these tasks. And there's a couple different ways to do it. The way that we're familiar with, right, is for, what's it, like something like let I equals 0, I less than tasks dot length, I plus plus. This is one way to loop. Modern JavaScript gives us a somewhat simpler way if I don't need an index counter. Can anyone remind me of the syntax here? Is it like T in tasks?
You'll have to, yeah, parentheses.
Yeah, I'm always getting my JavaScript and my Python confused. And it looks like I don't even need the let statement. Or maybe I do.
I thought it was a for of, no?
Yeah, it could be. I think I'm getting my syntax wrong here. Let's just do a quick Google.
I think it depends on what you're iterating. If it's an iterable or scriptable object, I think it's for us
Yeah, I think the
or for
in,
in.
yeah, the in might be Python.
Yeah, iterable object.
It's also JavaScript.
Oh, it is if it's an object. Got it. I see what you're saying. Right. If we were iterating through an object property. Thank you, guys. So that's a way to do it as well. But what we're going to find out with React is that often I need to transform each of my tasks. Um, and sometimes I need to make a copy of my tasks. So let's say we wanted to add today's date to each of these tasks. And let me make sure I have this. So that's more or less a date. I'm not sure if it's a string or a date object that's getting turned to a string by console log, but it's close enough. Now, I could inside this loop do that, but there's a slightly more elegant way using the map function. I can call map on an array. And as this description hints at, we can pass in another function as an argument that will then do something. And let me get a quick show of hands. Is map ringing bells? Does this look familiar to people? Okay, so this mainly, I take it, review? Cool. Actually, does someone want to walk me through then, like building a map here that's gonna add today's date to each task?
So you're gonna add your iterator. So we'll just say task. You're gonna use an arrow function with your curly brackets. And inside there, since we're working with objects, I believe we can just name a new object and set it equal to today, right? So we could do uh, to,
Something like that.
yep.
Yep, that should do it. So, and then what we don't need to type, but what's implicit in here is return task. And can someone describe for me, like in a sentence, what dot map does?
Uh, it's going to iterate over each object inside tasks and execute the code inside the curly brackets.
Yeah, execute the code in our callback function. And what does dot map return?
It returns a new array with the elements of that array being the product of the function within .map.
And if I console log tasks, will tasks have the date?
Yes.
Yes, it will.
No.
No, I don't think
No,
it
it'll be
mutates it in
tasks with
place.
date because it was assigned to tasks with date. I'm
Oh,
sorry.
Yeah, let's
Yeah, it doesn't modify the thing that the variable that calls it. It just returns that new thing without modifying the current array.
yeah, exactly. It actually makes a copy of each item. Um, and map here, as in think about we're mapping like, if a map like represents a territory. And I don't know, these are tasks. And then over here, this is the new one, tasks with date. And so, this might have ID, task, completed. And my apologies that my diagram is a little messed up here. But over here, because of our dot map, we do something to it. And in this case, what we did is ID, task, completed, and then date. So the original array is still there and it's untouched. And what dot map does is it goes through each item and performs some operation and maps it onto a new one. And if we run this, fingers crossed, this is exactly what we'll see. And it looks like I have a typo because I forgot to add a const in front of my variable declaration. And if we scroll up a bit, it looks like we actually do indeed need a return statement because I'm seeing a whole bunch of undefineds. So that was my bad. I was saying, oh, we don't need that. And I was totally getting my syntax confused. And now we can see here our tasks with date. But then, just like you guys were saying, the old unchanged tasks. And when we get to React, this is actually going to really matter that we've made a copy of this because of how React works. And this is sort of a core idea of the functional programming paradigm is you never modify data, you make a copy of it and you change that.
but it seems like the old list does have the date on it.
Does the old list have the date on it? It should not. Oh, you're right. Let's see. It looks like I did something wrong here then. Um, well, oh yeah, it does. Then I totally did something wrong here in
I,
this
I
map.
searched it. It's a weird thing of map. So it's supposed to be non-mutating, but it's important to note that if the elements of the original array are objects and the callback function modifies the properties of those objects, then modifications will be reflected in the original array as well.
Right,
Because both the
right,
new array and the original array hold references to the same underlying objects.
right.
So I guess something to keep in mind. It's not supposed to mutate in place, but in our instance, we are messing with objects, so it is going to mutate it,
Right, because we're dealing with pass by reference.
not pass by value, right?
Yeah. Yeah, excellent points. And this actually will pop up with React, right? So if we had if tasks was not objects and we were modifying a string or a number, the original one would be unchanged. But exactly like you said, because it's objects and JavaScript does pass by reference, we have here a reference to the original object. The way to fix this, and we'll actually see this pattern show up in React, is we actually want to create a new object, destructure tasks, and then add the new property. So we are actually creating a new object, and right here we are destructuring tasks. So this adds in, ID and task and completed. Does this destructuring syntax ring a bell, or is this new? I'm seeing a couple thumbs up. And we'll see this a ton with React. So this is actually good to see. And now we see our old one is unchanged. And with the new one, it looks like I still got something wrong in my code because I just see date here at the end.
Does date colon today have to be does date have to be a string?
I think you're destructuring tasks. The entire thing is the plural instead of the singular.
Oh, man. Yep. It's the plural. Thank you. That's the problem. Yeah. I'll often just use like the first letter because that's such an easy typo to make. Yeah, bang on. Thank you. Let's see how we do now. So old one, unchanged. Now we're cooking. Thank you. I was totally not seeing that. So now we've destructured the object. Um, this is syntactic sugar. There's another way to do this in JavaScript, but we don't need to see it, and frankly, no one uses it anymore. Um, this is way better. And this takes all the properties and breaks them out and puts them into this new object that we've created here by having these curly brackets. I could have also done it like this if that is a bit easier to read in terms of all the syntactic sugar, where I'm creating a new object and destructuring the old one. And then we avoid the pass by reference issue because we're not adding this to this existing object. We're adding it to a brand new one. And I just want to pause and check in and see if folks have any questions. How are we doing? Cool. I see a couple of thumbs up. Awesome. In that case, let's keep on rolling. So we've seen mapping, which is pretty cool. And let me go ahead and clear up some space here. I think we have a good sense of the shape of that JSON object. And we have some new tasks, tasks with date. There's another really useful function that again sort of uses this functional style, which would be filter. Um, but let's play around with map just a little bit more because this is one way to destructure, but there's another way to destructure as well. And let me just write it out here. And we'll just do const tasks with date again. And we'll do tasks.map. And in fact, let's just copy this whole thing down. So this is the same code that we just wrote a moment ago. But let's destructure a different way. Let's take this object and destructure it right here into its own properties. And just for fun, we can I'll console log ID just so we can see it in action. So this syntax takes an object and destructures it, and we can grab the properties that we care about. If I didn't care about ID, I could remove it and just grab those. And again, we're building a new object and we're just passing in each of those individual properties. And we'll actually see this a whole lot in React. And it looks like I have a syntax error. I might need an extra set of parentheses.
You were only missing one in the, yeah, you got it. Never mind.
Yeah, thank you. Oh, and completed is misspelled. It's a little subtle, but completed is grayed out, and there's these little squigglies here. And I wrote competed. And if we ran this code, we would get the exact same thing, where again, we'd have our updated tasks. And this is our most recent one, and we can see it built out. So we're actually going to see this pattern a ton in React. You can see that with the arrow functions, it can get a little finicky. Like I needed to add those extra parentheses to help the arrow function kind of understand its own syntax if I'm doing object destructuring there. That's something specific to arrow functions. Let's talk a little bit about filtering, and then we can take a break, and then we'll look at React.js. So obviously, if I've completed tasks, oh, and we'll talk about Axios as well. If I've got tasks, it'd be helpful to see which ones are completed. And I'm just going to use it. We'll use the tasks with dates. It doesn't matter. Or and let's go ahead and let's filter. And filter also takes a callback function. But what filter is going to do is we return a Boolean. If true, filter puts a copy of the item in the new array. If false, it filters it out. So I can just write return task.completed equals true. And this will return true when a task is completed and return false if it's not. And let's look at our completed tasks. Let me also, before I run this code, comment out some of these console logs so that we don't have just an infinitude of tasks printing to the screen. And we don't really need that. And it looks like I'm still executing some old code that I'll have to hunt down and comment out. In fact, it's this console log statement right here. I think. Yeah. But what we can see here is filter has gotten rid of all the tasks that aren't completed. And we could do the same thing for incomplete tasks. One moment, Carlos. And in fact, I can write this as a shorthand. I can just do return task completed is not true. Or if I want to make it simpler, I can just say task completed is false. But with arrow functions, in fact, there's a shorthand where if like I have a one-line statement, and this is what I got a little confused on before, I can condense that and I can drop the return statement. And I'll add a little console log to help us navigate our print output. And we can see here completed tasks and incompleted tasks. And the nice thing is this tasks with date array is unchanged and still has everything in it. Carlos, yes, sir.
Just I guess for peace of mind, does the on line 95 where you console log completed task, does that have the same the filter does filter have the same behavior as map? Is it altering the task with dates? Can we console log task with dates after 95?
Yeah, we absolutely can. And that's a really good point. So let's scroll up. So here's task with dates. So there's two things to note here. And this is where it gets tricky. Map and filter build a brand new array. Um, but you're correct. We didn't actually change the task object. And so that's why here with task with dates, these are the same. But you're correct. We still have the same pass by reference issue. Now, if in here I did task.foo equals bar, I do think we would then indeed see that show up in task with dates. Let's run this and find out. And in fact, we're seeing bar. Yep, because here's our completed tasks right here. And then this is the original tasks with dates. Is that what you were wondering about, Carlos?
Yep, that's it. Thank you.
Yeah. Excellent point. Excellent point. Um, so, a good practice when using map and filter on objects is like we did for .map. You probably want to create a copy of the object. I think that's a really good habit to get into. With .filter, a good habit is don't modify the object because that's not really the job of .filter is to modify the object. Um, this is getting a little more advanced, but we can combine map and filter together. For instance, my completed tasks equals tasks, let's say dot map T. The syntax is going to get a little tight. I'm just adding some property. And then it's called method chaining, and we may have seen this before. And let's add a little console log up here. And so here we can see that I can call map and it's returning an array, and then we're calling filter on it again. And the way you'll actually see this written is because unlike Python, white space is not syntactically meaningful for JavaScript. You'll often see this on multiple lines. And I think this is where I like to talk about the idea of functional programming as like data flowing through a series of tubes. And I think it's helpful to imagine this array flowing into here, right? And being modified, and then the output of that flowing into here. And then that's what eventually gets returned. You can see how like the syntax becomes very dense very fast. So I don't recommend going all in on it unless you're comfortable. I think it's more than okay to write it out the longhand way. In fact, you could even have like a function like do something, and you do stuff, and you could I don't know if we're filtering again, use a function that you define outside of it. So it I once you get comfortable with it, the syntax is very nice, but it's a bit of a learning curve. Yeah, great question, Carlos. What other questions do folks have around map and filter before we move on and take a look at Axios? Okay, and how are we doing? I know I think I've gone a little maybe too dense in some areas today because we still have React to cover, but hopefully kind of digging into JavaScript and this stuff is useful. Do we want to take a short break or keep rolling for like another 10 minutes? Roll.
Oh,
Let's do it. All right. Axios. So this is the last thing, and then we'll break, and then we'll look at React proper. And this is today's curriculum, and we've done a lot of this. We just did mapping, we did destructuring, we did filtering. Axios. What is Axios? Axios is a popular JavaScript library we can use instead of fetch. It provides a consistent and simple API for sending and handling HTTP requests, and it uses promises. And could I get a volunteer to just read out like these points of why we prefer Axios?
Why Axios over Fetch? Axios offers several advantages over the native Fetch API. Promises by default. Axios uses promises for handling asynchronous operations, making it easier to work with asynchronous code. In contrast, Fetch uses callback-based approach that requires additional work for error handling. Request and response interceptors. Axios supports request and response interceptors, allowing you to transform data or headers before sending a request or after receiving a response. Fetch doesn't provide this functionality natively. Browser and Node.js compatibility. Axios is designed to work seamlessly in both the browser and Node.js environments. Fetch, originally intended for browsers, requires extra work to use in Node.js. And error handling. Axios provides detailed error information by default, making it easier to identify issues during requests. Fetch requires additional error handling logic to provide similar information.
Awesome, man. Thank you. And now we're going to write a little bit of code and see Axios in action. And I'll just pull this up here as a reference. I am going to take a moment to just comment out all of my open console logs. Otherwise, we'll just have way too much stuff in there. So that ought to do it. In the interest of time, I think I'm not going to show sort of the counter example with fetch, but let's build this up with Axios. And you all have been writing async functions already with fetch, correct? Yeah. So this format is familiar, right? I can write a get Pokemon function, And someone want to remind me, why do I have to put async in front of this?
It allows for the waiting of the basically response. So it doesn't just try to run through the code. There's times where it'll pause and then continue on once it gets a response back from your API.
Yup, exactly.
Blocking IO.
Exactly. We've got non-blocking IO. So we need to tell JavaScript that we're making an asynchronous request here, and it may take a while, so JavaScript can handle that. And actually, it wraps this in a promise, which I won't dig into now. I will briefly point out, and I'll put this link in the Zoom chat. And have you guys seen this page on MDN? Or does this look new? Yeah, we've talked about this a little, not a lot. And the reason I'm mentioning it, I'm not going to dive into it now, but async and await are just syntactic sugar around promises. So if you get comfortable with promises, then you will get comfortable with async await. And the key bit is really up here because, as you guys pointed out, an HTTP request is an asynchronous operation and JavaScript has non-blocking IO. So how do we deal with making an HTTP request? And what if our program just keeps running and never waits? So a promise holds a value not necessarily known when it's created. And then we can have handlers with an asynchronous actions, eventual success or failure. So I'm gonna dump this in the Zoom chat, and if you don't mind, if someone could just repost it in maybe our questions channel, I would appreciate it. Um, and I highly recommend blocking out like 20 minutes, maybe even 30 minutes, and today or this evening, just reading through like the first half of this doc. Because if you get comfortable with promises, then everything becomes easier. So different syntax with async and await, but still a promise. And we've seen, if we did this with fetch, we could do it this way. And I'm just going to steal this from here. And we could console log our response. And in fact, let's go ahead and run get Pokemon and see if I have any errors and see what we get. And it succeeded. I hit the Poke API endpoint. We got a response. It's a giant object. It's got a status, 200 success message. We can see all the HTTP response error headers. E tags are for caching, information about the server. But then in the response body, this is kind of a pain. I'm not seeing the data that I want. And I think we might have to do something like this. We need to call a JSON method on fetch's response object, which is also an asynchronous operation. And so we need await again. And to be honest, that's a little bit of a pain. Axios does a lot of other things, but one of the things it does is get rid of the need to do that. So first off, let me import Axios, and you always want to have all your import statements at the top of the file. And this is also why this is nice that we're running this with npm. And now down here, instead of using fetch, let's use Axios. And this is going to be a GET request. If we were sending data to the server, we would do a Axios post request. And let's look at the response now. So this is looks very interesting. And by the way, a nice trick is sometimes with these giant objects, if you want to navigate it, just grab the whole thing and stick it in a file, right? And here's our response. And the JSON isn't very happy because I didn't do this very well. So this might not be as useful as I had hoped, because it doesn't have the double quotes on everything. So I'll just go back to the other way. But when you're grabbing like stuff from DevTools or other things and you have a big JSON object, that's a nice trick. So if we look at our response object, we see some similar stuff. We see the headers, but then if I scroll down far enough, there's all this other information. But here is this property data. And inside this is a giant object that has all of the response data in the result of the HTTP request, right? The payload of the response. So here I can just console log response data, no extra await needed. And I get the data that I want. Now, this is pretty messy. And in fact, I think the way to do this is let's rename this to be a JavaScript file. And just now I think it'll complain less. It's not perfect, but it's better. Yeah, it's still a little hard to navigate. So usually I grab it from DevTools from the network tab and it's better formatted. But we can see here, the Poke API response has a ton of stuff, but we can grab it pretty easily with response.data and we can get the bit that we care about. So Axios is pretty easy to use. We use it like fetch, but we don't need to do that extra step. And especially as we do more and more with React, Axios is just going to make life easier and easier. So this is a good stopping point because we should take a break and then dive into React. So I just want to check in to see what questions folks have before we break. Andy, yes, sir.
I was gonna ask, what's the point of? It's not really what's the point of, because I was just wondering if we're doing async, why are we constantly have to prefix with an await if async is supposed to like kind of be doing that, right? It's asynchronous. Um, I'm just maybe it's just still foreign language to me, but now we're replacing await. No, it's just in addition to an await, now we're doing axios.get. I'm kind of confused about this.
Yeah, that's a good question. Async and await work together. Async tells JavaScript that stuff inside this function is happening asynchronously. But await is when we tell JavaScript it's this specific bit right here, this function that we're calling, that is an asynchronous operation, and you're going to need to use a promise to wait to handle this response. If we wanted to, we could potentially do like multiple asynchronous calls within an async function. For instance, if I needed to get like Pokemon follow-up data, so you might write an asynchronous function that has multiple awaits inside of it, though that's less common. But I think the main thing is we need a function that's sort of a wrapper for everything, and we need to tell JavaScript that the function as a whole is asynchronous. It doesn't really return anything, but then inside we still need to tell JavaScript like what line of code specifically is executing an asynchronous operation, because we're telling JavaScript, hey, when you get to line 116, you're going to have to wait until this is done before you go here to line 117. because that's what the await here does. It guarantees that JavaScript will not go from line 116 to line 117 until this is done.
So the a you have to have async to in order to use the await.
Exactly.
Okay.
Exactly. Yeah. If I don't have async here, we have that squiggly and it's going to throw some sort of error.
Okay.
Expected reserved word. Yeah.
Okay.
Good question. You got to use them together. All right. Let's take, you all want to do 5 or 10? 5. Let's do 5. And when we come back, we'll look at React. All right, folks, thank you very much, and I'll see you all in 5 minutes. All right. So we did a pretty deep dive into map and filter and ran into the unexpected pass by reference nature of JavaScript. And we looked at Axios. And Jest will return to later for front end testing. There's another front end testing library called Cypress that we'll see. But now we're finally ready to build and scaffold up a React project using Vite. Um, and could someone just read for me this first part here under what is Vite?
Vite is a
Do,
fast tool that is designed for the modern web development. It is known for speed and efficiency in the development process. Vite is not a traditional bundler like Webpack or Rollup. It leverages modern JavaScript features to provide an extremely fast development experience. Some key features of Vite include instant server start, fast hot module replacement, or HMR, efficient code splitting, out of the box support for popular front end frameworks, including React, Vue, and Svelte.
Awesome. Thank you. And does someone else want to read what is React?
React is a popular JavaScript library for building user interfaces. It was developed and is maintained by Facebook. React is known for its component-based architecture, which allows developers to create reusable UI components and build complex user interfaces efficiently. Some key features of React include virtual DOM. React uses a virtual representation of the DOM to optimize updates and improve performance. Component reusability. React promotes the creation of reusable components, making it easier to manage and scale your UI. Unidirectional data flow. React follows a one-way data flow, which makes it predictable and easier to debug. Rich ecosystem. React has a vast ecosystem of libraries, tools, and community support.
Awesome. Thank you. Yeah. And so just to kind of summarize this, as our JavaScript projects get bigger, we have image assets, we have HTML, we have CSS, we have NPM. We need what's called a build tool and then JavaScript with React. We need a build tool to help us manage all of this. Vite is a build tool. There have been others in the past. Vite has gotten pretty popular. It is not only for React, but React is a super common use case. It's going to give us a tiny little web server, the Vite dev server, that has some really nice developer features. So as soon as I change my code, I see it reflected in the browser. And then there's some stuff here that we don't have to worry about. React, we will get into all this stuff over the next week. Today is really just an introduction. And if we take a quick look at their websites, oops, excuse me. There we go. See, Vite is called the build tool for the web. It came out maybe 4 years ago now, but it's gotten pretty popular. Um, Things like hot module replacement have become pretty standard. Um, it does a whole bunch of stuff. It's always a good idea to take a look at the getting started page, where it kind of walks through things. We're about to build our own Vite project in just a minute. And then let's look at React. So this is Facebook's user interface component library for building web, and there's a way to build mobile iOS and Android native UIs as well with React. And it uses this sort of component approach. And this is what we're going to be building in just a little bit. And this Facebook React site is incredible, by the way. I highly recommend going through their quick start. Um, and really, along with our own material, the tic-tac-toe tutorial, and tomorrow I'll point out thinking in React. And their documentation is pretty incredible here under Learn React. And I would strongly recommend trying to block out some time to, after doing our coded assignments, work through what they have here, because I think they explain stuff really well in a different way. And if I hop back just a bit, to the homepage, if it lets me get there. There we go. We can see here, we're going to see this in action in just a minute, but we see a lot of things we've been talking about. We see object destructuring here. Some object has been passed as an argument to this function. We see a return statement. We'll talk about how we can have this HTML-like syntax called JSX in JavaScript in just a minute. And you can see how like there are different parts of a component. And we're going to really dive into React tomorrow. Today is going to be more code and more scaffolding. But again, just to give you kind of a preview of where we're going, we can see object destructuring here. We can see working with stuff. We see a dot map to map through multiple videos. And we'll learn about like using multiple components later on. But we can start to see some of the things we've been covering earlier. But for now, let's get started with a new React and Vite project. So let me give myself a little bit of space here. And I'll put this up here for anyone who wants it. So I am going to navigate into the part 2 of our demos and notes repo and create a new Vite project. And just like with the npm init, it prompts me for a bunch of things. This part is really important. If you're doing npm create Vite, we need to choose React. We're not going to use TypeScript. TypeScript is really cool, but it's outside the scope of this course. Don't worry about this SWC option. We want plain old JavaScript. So now let's see what this has done for us. And if we look in here, and let me put this off to the side and follow these instructions, and we go into our project that we created, we can see a whole bunch of things. Some things look familiar, like package.json, and there's a bunch of scripts here already. Dependencies looks familiar, right? It's created its own README. It has a config file for Vite, which later on we will add things to, but we can see how it's set up to use React. So for right now, we don't have to worry about this. A get ignore file that it's generated to ignore all the kind of things we want to ignore. A configuration file for ESLint, which is a tool for linting, for making sure our JavaScript syntax is correct and catching like bad practices like double equals. I'll talk about the public and source directories in a moment. And we have an index.html page, which is really interesting because in the body of this HTML file, there's a div with an ID of root, and this is going to be really important. And then we see here a script that's loading some JavaScript, and we see here type module. We were just talking about ES modules, and this is an example of now that the browser supports ES modules, we can load a JavaScript file that way. And then we see from the source directory main.jsx. And the X is important, and it stands for, what does JSX stand for? JavaScript XML. So it's an acronym with another acronym living inside of it. And this is basically how you use React. And it's a syntax that we can use in JavaScript to let us write HTML, basically, or components. But this is where NPM and all this other stuff comes in, because I'm not going to get too into it today. But if we look at what some of this JSX looks like let's go into the source directory and look at this main JSX file. This is not JavaScript, right? These angle brackets and stuff, this is not JavaScript. So we need NPM to run the React library and do some work on this before it gets run in the browser. And Vite and NPM do that work under the hood for us, which we'll talk about later. And let me pop back here just so we can have this here. And we can see here in the SRC, the source directory, we have our code. And this main JSX file is the file that was referenced in index.html. And we see that main JSX imports the React library that we should install using npm. And this is going to look at the package.json and install the dependencies and developer dependencies to help us during the installation process. And it's creating that node modules directory with all the stuff inside of it. And it's creating the package lock directory. And we see that we need not just the React library, but the React DOM library for interacting with the browser's DOM. And we see here we import, and let's hop over here. We import this function app from app.jsx. And this is where it starts to get interesting. And let me just give us sort of some empty space here so that we can focus on our code. And I think the split might be a bit too much. So app is a function, but inside the return statement, we see this JSS syntax that looks an awful lot like HTML, but we see on-click, we see JavaScript hiding inside here, we see all sorts of interesting things. And we'll walk through this in just a minute, but just to kind of finish the tour of a Vite project, we also see that we can import a CSS file. And this is where Vite does work for us under the hood in terms of when we actually run this. And there's a bunch of built-in CSS. And there's another CSS file here that I'll kind of walk through in a minute. And then in this public directory, we see there is an image asset. Now, all of this was created in that Vite project directory. If I want to create a Vite project, but not put it in a new directory, I can just put a dot there and it does the same thing. But just note how it didn't create that extra layer of the directory. Otherwise, everything is the same. And what we're going to do now is run this dev script, which is sort of the most important script for us with Vite and React. And it runs this program Vite that runs what's called the Vite dev server. So now if on localhost, I go to port 5173 in my browser. we can see that we have our app running, Vite plus React. And in fact, if I go here in source to app.jsx, I see something that looks suspiciously like what we're seeing here. And if I use the elements tab to do a little inspection here, we can see there are some similarities. In fact, let's trace this from the very beginning with index.html, which is indeed the HTML page that's been loaded here. We see it's the same. There's a lot of stuff that's been added in the head. But we see here in the body this div ID root from right here. And then below this script tag type module that's where the browser is loading and running this main.jsx file. And if I go in here, there's this really interesting command, create root, react dom.create root. And create root lets you create a root to display React components inside a browser DOM node. And we see document.getElement by ID root dot render. And then we have this is what's called a React component. When it looks like HTML, but the name is something else, and it starts with a capital letter by convention, that's a sign that it's a React component. And in fact, this part we can get rid of. We don't need, and I do recommend getting rid of that for learning purposes. And we're what's called mounting our app, our parent, our root component, our top level component, and it's getting built inside of this node on the DOM. And if I go here and I open this up, I see all this other HTML. And if I go to app.jsx, that's exactly what we see, right? And the Vite dev server, what they call the hot module reloading, what that means is if I change this, so this H1 tag here now has a bunch of exclamation points, the Vite dev server reloads this for me and we see the change here. And so if I wanted to add another tag here, React is creating DOM elements using JS. You would see that show up. There's a lot of stuff here we're not going to worry about today, but let me pause and see what questions folks have before we continue. Carlos, yes, sir.
What was that command you gave after you did npm install? It was something dev,
Yeah, npm run dev.
run dev. All right.
And this is where package.json is your friend because it's sort of your command center. Because if I go here to scripts, I can see the different scripts to run. And by convention, dev is going to run the dev server. By convention, when you write a README, you should also provide an explanation of the package.json scripts because Vite has a website explaining stuff. You know, that's where they put the stuff there. But if I had built a React app in my README, I would explain what all the different scripts do. Yeah, great question. What other questions do folks have? Okay, how are we feeling? Because is this a lot? Are we feeling pretty good? What's sort of the vibe? I'll take that as somewhere in the middle. Cool. So there's a couple things we're not going to worry about today that I'm going to get rid of. This use state we're going to learn about in the next couple days. It's pretty cool. What it does is if I click this button, it gives me interactivity. Today, we're still, for your coding assignments in the afternoon, you're going to do stuff the old school way with JavaScript and working with the DOM. But over the next couple days, we'll learn how to use what's called React component state to not have to do that anymore. But we're not there yet. So I'm going to get rid of this, and we're going to get rid of this stuff here. So this button is going and this is going, and this is going. And this has simplified our code a bit, right? And if we walk through this line by line, we see that we're importing an SVG, an image asset, essentially, from this assets directory in source. We see we're importing the Vite logo from there as well. Well, you know what? I want to simplify stuff. I don't want to have to worry about those things. But if I look here, this looks just like normal HTML. And the anatomy of a React component is, you name it starting with an uppercase letter. And a React component is a function that returns stuff to be rendered to the DOM. So if I did return hello, that's what we would see. And if I look inside this div ID root, React has just stuck this message hello in here. And if I did return 4, we'd see 4. But if I do return an object, I'm actually surprised we don't get an error, but we don't really see anything. Really, what you want to return is JSX that gets turned into HTML. And so I could do this. And now inside this div, we see this H1 and React.js running in the browser. The JavaScript has created this DOM node. It's turned this into HTML. Often you'll see stuff wrapped in parentheses. React does not want you to have JSX elements at the same level. Everything needs to be wrapped in an enclosing tag. So here, if I wrap these inside a div, React will become happy. Right? So this is sort of like rule 1. What you return is the stuff to be rendered to the DOM, and everything's got to live inside one element, right? Like a tree. And in fact, that's exactly what it is. Now, it can be kind of annoying to write tons of divs. So React has created what's called a fragment. That's sort of a placeholder. And note how we don't have that extra div here anymore, but we still have hello and goodbye. And so if we kind of look at this big return statement here with fresh eyes, we see a fragment. We see a div holding 2 links. And you know what? Let's get rid of the Vite logo. Let's get rid of the React logo. Let's get rid of this now empty div. We in fact see a bunch of CSS imported in app CSS. And while this is great, this is not the CSS that I want to write and work with. So let's get rid of that. But there's still more CSS. Here in main.jsx, there's another CSS file. And this is sort of the master file because it gets imported first. And everything here gets run first. And then this app component that we were just looking at gets mounted. So let's go to index.css and get rid of all of that CSS. And now we have a much simpler planner page. And we're not using these image assets, so we can get rid of them. And this class name doesn't exist, so we can get rid of that. And that class name doesn't exist, so we can get rid of that. But we can do all the same stuff here that we would normally do with plain old HTML. And let's see, what does it not like? Provide an explicit type prop for the button element. I'm not going to worry about that. And if I go here to the JavaScript console, which is your best friend because it will show you errors as you write code. And in fact, let's just refresh this to make sure I don't have any errors. We can see our hello button being clicked and in action. So these JSX elements get rendered into HTML. Just like with HTML, we can add JavaScript, but I can do so much more here. If I add a console log here, this gets run first because what React does is it runs this function and it executes it top to bottom. But this return statement returns what React then renders to the DOM. So let me just pause here and check in and see what questions folks have or what people are curious about. How are we feeling about React? I see a thumbs up on a scale of like 20 to 100. How are we feeling?
I won't know until I try it and run into issues,
Fair.
but it makes sense so far.
The scale inclusive or exclusive?
Inclusive.
Okay. I have no idea.
Fair enough. No,
Sounds like something a
I
developer
appreciate
would
it.
say.
Sorry?
That sounds like something a developer would say.
Yep.
Ask a lot of questions and then, oh, I don't know.
That is indeed exactly like a software engineer. Well, I love to over communicate, so I don't mind continually asking questions. Um, I hope hopefully people are feeling pretty good. Hopefully this project structure doesn't feel really weird. We're gonna add more and more stuff to this as we go. But for now, let's see how to build something in React using the tools that we know.
Just a quick question before we move on.
Yeah.
Um, just looking at the structure you mentioned, which, like looking at the hierarchy, which one would be the first one that we would be developing? You know, I see main JSX and I see app JSX. Which one is like prioritizing
Yeah.
the function?
Great question. App.jsx. This,
Okay.
yeah, this is where we're going to do most of the work. Main JSX really has one job, and we don't touch it otherwise. Later on, we'll see some extra stuff, but like main JSX's only job is to take this app component, and this is how you render something in React. For instance, if instead of app, I wanted to put here, like, I don't know, a div, and let's give it a class name. And inside here, put an H1 and say hello world. Well, see this root component that main mounts to? It mounts that stuff right inside. And that's main's job. The beauty of React is it lets us make components, which is like a combination of layout with this JSX that get turns into HTML and CSS. So we have structure and layout, and then we have logic with the JavaScript. So we get to combine it all and bundle it into a component. So with OOP, we had classes, but with React, we have components. And the components form a tree, just like the DOM elements form a tree. And we'll talk more about that tomorrow. So I import my component, and my component is a function, right? That's sort of the confusing bit. And I think the mantra is a component is a component in React is a function that returns stuff to be rendered to the DOM. A component is just a function, but it returns stuff to be rendered to the DOM. And in fact, later on, we'll be adding in arguments to components and rendering components inside components, but we're not there yet. But what main.jsx does is this app component is like our where we put most of our code, and by convention, it's the parent or the root component for our whole application. So we import it here, and then the way we render or execute a component, the way we execute this special kind of function is by using the JSX syntax.
Okay. So everything you said makes sense. So it's like the React gives you like the incentive of you have to think of making the DOM to be uh, like not user friendly, but more of give the user ability to I guess work with whatever they're seeing the browser is from the get-go you are thinking about making it functional. It's not just a here's the web page.
Yeah, exactly. These things are called single page apps, and I always like to use Google Maps as my example. Um, and also think about Facebook, which I haven't logged into in ages. Otherwise, I would demo it as well. React was created to build front-end web apps like Facebook and Google Maps. This would be a whole lot of work to do with plain old JavaScript the way that we saw in the full stack week, right? This level of interactivity. But if you start thinking about, oh, well, this is a component, and there's a map component, and there's a menu component, and there's a menu item component, and it's all sort of this tree. Like if you need to build something like this is when something like React, well, I didn't realize I was going to do that. Something like React really comes into its own.
Okay. So yeah, so essentially the front page you're seeing is a component, and then whatever you click is another component. It all just ties itself to it. Okay, that makes sense.
Exactly. It's components all the way down until you get to like this H1 tag. They call it a JSX. I mean, you can see here intrinsic element. You can basically think of that as an HTML element, right? That's like your atom of this universe. At the end of the day, everything is composed of these JSX elements. And we'll see that tomorrow when we build stuff out more with components. Right now, I just want to demo, though today's going to be sort of an interesting day because we're still going to do some stuff the old school way. Because today, your job is really to get used to like the Veed project and the scaffolding and the setup. And so today, like just to demo making a number guessing game with React, but still using some of the old school techniques that we've seen. Um, Let me go ahead and let's just talk about what the guessing game is. And I'm going to do a little bit of pseudocoding here. I want to have an input field for the user to guess a number. I want to have a submit button. And the goal here is the user guesses a number until they get it right with feedback of hot or cold. So, for example, if the number's 10 and I guess 5, it would say, too low or something like that. So just to kind of map out what I want to do, I'm also going to want to generate the random number. And I'm going to want to give the user feedback if they are too high or low. I'm going to kind of separate this into parts. This stuff is sort of like layout, right? And this stuff is more like logic. And I'm going to actually start with the layout. And we're going to make a guessing game. And I think we're going to need a form. And the form's going to need an input field of type number. And I'm going to need to close it properly. And let's give them a little bit maybe of an instruction. And then I'm going to need a submit button. And it looks like I have an error. Let's see what my error is.
Line 23, the closing tag.
Line 20. Oh, thank you so much. I'm a little surprised I didn't get a red squiggly there. Yeah, I'll put the console here. And so this is the beauty. So this is what they call hot module reloading, where the Vite dev server is constantly refreshing for me as I go. So this is good, right? I need a little more work here. I've got this handle click button. So let's say I want the form when the user submits the form. I want to call handle click. I'm going to need to do a little work here. In fact, I might need to grab the event that's generated and pass that in because we're eventually going to need to grab the actual number that was guessed. I need to prevent. Can someone remind me what prevent default does and why I need it?
So when it's like a submit button or like any type of form, when you click that submit, it's going to try to pass that in as a query inside of your HTML link at top, and it'll cause the page to like kind of reload as well.
Yeah, exactly. It's a holdover from the original days of the internet where there was no JavaScript, where the only way to submit a form was to make a post request to a server, which required a page refresh. So this doesn't do a lot, but I've got my layout, I've hooked it up to a handler function. If I don't have that prevent default, note that the page refreshes. And we can also tell because see how this hello world shows up every single time. When I have prevent default, note that that hello world doesn't show up every single time. And we'll talk more about that later, but this app gets rendered once and React isn't going to re-render the whole thing all the time. And that's kind of what we want. And so we really need that prevent default. And we'll learn more about that tomorrow, but just to kind of point that out and put it in the back of your heads. So now we're getting closer, right? Um, can someone remind me, how can I get the number from this form? Like once I put in 44 in here and hit submit, how can I, print out the number here just for testing purposes? What pieces am I missing?
So you'd have to put an ID on your input, and then you'd have to grab the ID by element, like grab element by ID, and then up top, and then you're going to grab the inner HTML text for it.
Yep, totally. We'll call it user input. And exactly like you were saying, we'll just call it guess equals document get element by ID. User input. And let's see how we do here.
For that guess, I'm just gonna have to do inner HTML text.
You are almost definitely right. Thank you. Let's see if
Or inner HTML, yeah.
let's see if that does it.
Is it value instead?
Yeah, it might be value.
Let's try value. Nice, thank you.
Thank Carlos. I'm a little rusty on my HTML.
Well, me too. So we're cooking, right? We've got the input field, we've got the submit button, we've grabbed the guess from the input field. Let's generate the random number. And I'll just code this one out. And we'll just call this random number. And I'm going to use math.floor to take math.random, which gives me a decimal value between 0 and 1, multiply it by 100, add 1 so we don't get 0. Put that there. Now, let's talk about what to do with this random number. Right? The answer is 6. And this is good because I don't see that popping up all the time. But when I'm debugging, it might be nice if I can see the answer. So I think what I'm going to do here is put another H2. We'll give an ID. We'll call it show answer. Answer is, and now this does bring us to another React feature, which is how we can sort of embed JavaScript inside our JSX. And we do it with curly brackets as a sort of escape. So for example, if I had done, 4 plus 3, we get 7. So I can run JavaScript inside these curly brackets. And this is one of the cool parts of React and JSX. It turns out this is a great template language because I can mix logic with my layout. So we'll just kind of leave that there. But let's go ahead and let's see if we can't set the display property of this answer to hide it. And I think what we'll do is we'll use a CSS style and we'll say display. Let's see if I get this right.
I think it's hidden.
And I think I might need to do it like this. And it might need to be an object inside. There we go. Display. What's the normal way of viewing something for a CSS display property? Oh, there we go. Let's go here to elements. Let's inspect. Let's find our answer element. Here we go. and let's give ourselves a little more room. Display block. That's sort of the default display, I think. So if we change this to block, right? So I've got none and I've got block. So what I really want is I want some variable, and we'll just call it let display, we'll call it just answer display, and we'll set it to none. And we'll come back to that later. But over here, we'll use that variable. And if I change this from none to block, the answer shows up. So we'll come back to that when we add in our interactivity. But now I can hide and show an answer. I can grab a number. I think the next step here is once I grab the number, check if the number is too high, check if the number is too low, check if the number is a correct guess. And then we're going to need to display some sort of answer to the user. So I think what I'm going to do is down here, let's make a div and let's give it an ID and we'll just call it user message. And we're going to leave it empty for now. But what we're going to do is if guess is greater than answer, if guess is greater than random number, and in fact, I think we need to do a couple other things here. For one thing, let's grab I'm going to rename this to result for simplicity. And CSS display prop for showing the answer or not. And I'm sort of combining two different techniques here just so we can see them in action. So we're going to grab that DOM element result. I'm going to make sure I have the name right. Excuse me. And now we can do our checking. And I can say, too high. Result.inner HTML equals too high. And let's just test that out because I've written a lot of code here and it might be a good moment to pause and go over stuff. So first of all, let me change the answer so we can see, so I can know if this is correct. So it looks like I did something wrong in,
Your inner HTML looks funny.
oh, yep, thank you. And it's a great example of a non-breaking error, which is the worst kind because we were not seeing it in there. I wasn't seeing any sort of error message. Excuse me. So the answer is 20. So let's try 30 now and see what happens. Interesting. So we get here, but we don't get inside too high. So I'm doing something wrong.
Are you supposed to pass if guess that value as well?
Say that again.
In your condition for the first if, this is
Oh,
guess that value.
well, we should be getting guess from this document.get element by ID. Oh, I see. You're absolutely correct. I kind of combined, let's simplify this and let's say dot value. Guess was the element, but it wasn't the value. And let's see if that helps solve it. So if the answer is 65, if we go higher, now we got it. Thank you guys. Bang on. So just to recap, guess, I wasn't assigning the actual value to guess. I was assigning the DOM element to guess, and that was a problem. And then I had a typo here. So now guess is indeed the value of the guess. For instance, 90 is too high. If I go low to 20, nothing will change. So let's implement if the value is too low. Andy, yes, sir.
Um, I feel like normally if that issue would happen in like not in HTML and JavaScript, it would spit out an error. Here it's like it's kind of hard to debug because it's not throwing out an error for something like that.
Yeah, well, yeah, we ran into it. Yes, I think the short answer there is yes. There are going to be times where we're going to get silent errors. Um, but what we're going to see today is sort of a hybrid. Like once we learn more about React tomorrow, we're never going to modify the DOM directly like this again. React actually gives us tools to do that, and that will sort of reduce the chances for those kinds of errors. But there's still sometimes will be silent errors, as with all coding. But you raise a good point because in general, whenever you can, you want to kind of avoid embedding, you know, like semantic meaning or structure in strings like this, right? But today it's going to be sort of a hybrid day. And so we can see here that my logic for too high or too low is working. And if it's not too high or too low, it must be just right. So let's go ahead and now show the answer. Or we'll say H3, U1, correct. And over here, we will change that answer display from none to block. So the answer is 26, which I'm going to remember. Actually, we'll change it here and we'll get a new answer. So the answer is 17. And I might have to deal with too low showing up as a default message, but 11 should be too low. 111 is too high, but 17 is just right. U1. And in fact, I think what I need to do is we need to sort of initialize result.inner HTML to be empty. Probably like that. So that way nothing is there for a new guess. For the answer is 68. And now if I guess 68, it's we see U1 correct. Oh, we should be seeing the answer being displayed. I must have some sort of syntax error on there because we have almost everything else working. But we've gone a bit over time, which I do apologize about. So why don't we pause here and take questions and then we can break. So I know we covered a lot of ground here, but I think the big things to recap are, first of all, a component is a function that returns stuff to be rendered to the DOM. And we call that function by rendering it using this HTML-like syntax. This is when we actually execute our app component. And a component lets us combine logic with display. And if I want to put JavaScript inside sort of my display, my template, so to speak, I can use curly brackets because this return statement has to be stuff that gets rendered to the DOM. And every time something in here changes, React re-renders the component, which we'll talk more about tomorrow. And everything has to be inside one parent element, um, which is what we use this fragment for. And then we use the techniques that we learned in the full stack sort of module to manipulate the DOM. Tomorrow we'll see how to do it the React way, but for today's assignments, you'll sort of do it the old school way where you need a form, there's a handle click, we need to prevent default, and we need to use IDs on elements to grab values. But we saw here how, well, I need to fiddle with this a bit to get it working. We can embed by embedding like JavaScript variables, say for CSS styles, we can make our page more dynamic. And same here with displaying numbers as well. And let's see if this works or if there's still something not right. So there's something wrong here with my logic, but we sort of had it working before. And then we see that like inside these curly brackets, we can do more than just pass a variable. We can actually do any sort of JavaScript at all. So that's React. Um, and the assignments for today are going to be really just getting our hands on it. Um, we're going to want you to build a simple React app using Vite and fetch some Pokemon data. And don't worry about going beyond what we learned today. Use the techniques that we sort of saw here for the guessing game. If you've worked with React and you want to, use the other stuff, go for it. But we're going to do this a step at a time. And tomorrow we're going to dive more into React. And then the other assignment is very similar. It's building a to-do list in React. I do strongly recommend this reading assignment. We made it required for a reason, and it's in the class Google Drive that you all should have access to. We're going to see a lot of concepts come our way tomorrow and onwards with React. So please do read this. And then the last thing I would encourage you to do is like spend a little time with the React docs in Facebook with the link that I shared. I thank you again for your patience for running a bit long today. I'll do my best to keep it sort of like within the lecture hours for tomorrow and onwards. I think we'll be a bit more focused tomorrow too. Today we covered a lot of ground. So thank you very much and have a great weekend. Or sorry, I'm been on Zoom a lot too. Have a great lunch. And I can stick around for a couple minutes if folks have any questions about stuff.